You know that feeling, the snap of a good chocolate bar? That perfect silky melt-in-your-mouth texture? Well, it might feel like a simple pleasure, but trust me, it is anything but simple. Behind every single one of those bars is this incredible world of science. It's a whole journey from a humble little cocoa bean to the treat we all know and love. So, let's dive in and unpack the science that makes it all happen.
So, have you ever really stopped to wonder what makes chocolate snap just so, or melt in your mouth perfectly, or just taste right? Yeah, that texture, that whole experience, it is absolutely not an accident. It's all thanks to food scientists who have to solve one fascinating problem after another. I mean, we're talking a battle against spoilage, a fight against stickiness, all to get that flawless finish.
Okay, so our journey starts right at the beginning. We're on the farm, where the cocoa beans have just been picked and fermented. And right away, the makers face their first and maybe most urgent challenge. It's a frantic race against the clock to get the water out.
So here's the first major problem. Once a cocoa bean is fermented, and that's the process that develops all those rich flavor building blocks, it is literally a ticking time bomb. Why? Because it's almost 50% water, and all that moisture makes it the perfect breeding ground for mold. So the race is on to dry these things out before they're completely ruined.
But here's the thing, it's not just about, making them dry. This is all about absolute precision. The target moisture content they're aiming for is exactly 7.5%. Think about that. If you go too high, the beans spoil. If you go too low, they get all brittle and break. It is an incredibly delicate balancing act.
So how do they actually hit that super specific target? Well, the traditional way was just leaving the beans out in the sun, which takes about 30 hours. But now, with modern tray dryers, they can nail it in just 8 hours. I mean, from 30 hours down to 8. For a producer, that's not just saving time, that is a complete game changer for their whole operation.
But that brings up a really interesting question, doesn't it? We always kind of assume that the slower, more traditional method is better. It's more artisanal or something. But is that actually true here? When it comes to drying cocoa beans, is faster automatically worse?
Okay, get ready for this, because this is the surprising part. Scientists have this thing called a cut test to score the quality of the beans. And it turns out that super fast modern tray dryer, it doesn't just save time, it actually produces a higher quality bean. The tray dryer scores a 985, beating the sun-dried method's 960. So yeah, in this case, faster is actually better. Who would have thought? All right, so we've got our perfectly dried beans. Let's leave the farm and head over to the factory. Because now we face a totally new challenge. How do you transform these solid beans into that smooth, luscious, liquid chocolate we all dream about?
So the next problem is this. The mixture you have at this point, it's basically fine cocoa and sugar mixed into cocoa butter, it's thick, it's gritty, it's almost like a sludge. And the science of turning that into a silky smooth liquid has a fancy name, rheology. And the secret weapons in rheology? These tiny little molecules called emulsifiers.
Now, you can think of these emulsifiers as a two-part team, like a dynamic duo. First up, you've got lecithin. Its job is to control the ongoing flow of the chocolate. Then you have this other emulsifier, called PGPR. It's the specialist that handles the start of the flow, that initial push to get things moving. So two very different but totally vital jobs. Let's break that down. Plastic viscosity, that's lecithin's specialty, is really just about the thickness. It's the energy you need to keep the chocolate flowing once it's already moving. So if you have a lower plastic viscosity, it means you've got a thinner, more free-flowing liquid. Simple as that. And then there's yield stress. This is that initial hurdle, the get-up-and-go energy, if you will. The ketchup bottle analogy is absolutely perfect here. You know how sometimes you have to give that bottle a really big squeeze to get the ketchup to start coming out? That's high yield stress. A low yield stress means it flows easily right away. And that is what PGPR is there to manage. Now, this is where it gets really cool, because this scientific stuff connects directly to what we actually feel. A study from the NIH found a direct, measurable link between this property, the yield stress, and a sensation we all know, stickiness.
So what's the big takeaway here? Well, it's a trade-off. Lecithin is fantastic for making the chocolate less thick, for reducing that viscosity, but if you add too much, it has this side effect of increasing the yield stress. And what does higher yield stress mean? Yep, it makes the chocolate feel stickier in your mouth. So for every chocolate maker, it's this incredibly delicate balancing act.
Okay, so we've figured out how to dry the beans perfectly. We've mastered the physics of how chocolate should flow. But there's one last absolutely massive challenge to tackle: consistency. Think about it. A big chocolate company might be getting beans from dozens, maybe hundreds of different farms in countries all over the world. So how on earth do they make sure that every single batch meets the exact same high standard? It's a huge problem, right? What they need is a universal rulebook. And that rulebook exists. It's called the ISO 2451 standard. This is the global benchmark. It's a serious international agreement that spells out the exact quality requirements for every single cocoa bean, and it doesn't matter one bit where in the world it was grown.
Remember that cut test we talked about earlier? Well, it's a huge part of this standard. It's this super meticulous process where inspectors take a sample of beans and literally cut them in half, one by one, so they can look inside for any hidden flaws.
And what are they looking for? They're on the hunt for the specific enemies of quality. We're talking about things like internal mold, slatty beans, which is a dead giveaway that they weren't fermented right, any little sign of insect damage, or even beans that have started to germinate. None of that is allowed to pass.
And just take a look at how strict these standards are. I mean, to get the top grade 1 classification, a whole batch of beans can't have more than 3% moldy beans, or 3% slaty beans, or 3% insect-damaged beans. We're talking about a system of precise, totally objective quality control that comes down to a single percentage point. It's intense.
So when you put it all together, you realize the journey of chocolate is anything but simple, right? From that crucial first step of drying the beans, to the complex physics of getting the perfect flow, all the way to that rigorous final inspection, every single step is a calculated, deliberate decision. It's all guided by chemistry, physics, and hard data.
So the big question is chocolate just a simple pleasure, or is it a masterpiece of science? It really makes you think, doesn't it? The next time you unwrap a chocolate bar, just take a second and remember, you're not just holding a simple treat, you're actually holding the delicious result of a whole series of solved scientific puzzles. It's pretty much a masterpiece of food science right there in your hands.